Hello everyone, welcome to Driven Math and Physics. So we are presented with a circuit that has EMF of 17 volts from the battery, and then we have terminal voltage as 16 volts. Okay, we have this resistors 4 ohm, this one is 12 ohm, this one is 5 ohm. So we're going to label this number 2, this number 3, this number 1. Okay, and then we have V1 and the ammeter there as well. They're saying switch S is closed, and then they're saying energy passing through the 4 ohm resistor is 9 joules per second. That's actually power. So through the 4 ohm resistor there's 9 watts of power passing through. Joules per second is watts. Okay, so they want us to find the reading of the ammeter. Simple. So let's start with 2.1. We know that power is equal to I squared R. So if we make I squared subject to the formula, it will be P divided by R. And if we make I subject to the formula, it will be the square root of P divided by R. If we make substitutions there, it will be 9 watts divided by 4 ohms. If we do the square root of that, we'll end up getting 3/2 amperes, which is equal to 1.5 amperes. So instantly we know the value of the ammeter reading is 1.5 amperes. Okay, now they're asking us to find the reading of the voltmeter one, this one. Okay, so this one is reading the voltage across the parallel network, especially the second branch. Okay, so if we're going to solve that one, we need to understand a few things. Okay, so we said that EMF is 17, terminal voltage is 16. Now we need to understand that the voltage, okay, from the battery, the voltage is the same here. V3 is equal to V1. We need to know that. Okay, so let's calculate V3. If we're going to find V3, that value will be the same as the voltage reading of the voltmeter. Now, how do we find that? We know the current across the 4 ohm resistor. We know the resistance. So it means V3 will be equal to current times resistance. Current 3 times resistance 3. Now, if we substitute everything, the current is 1.5 amperes multiplied by the resistance is 4 ohms. Okay, if we multiply everything, it will give us 6 volts. Okay, so it means across this branch is 6 volts. That means that V1 is equal to V3, which is equal to 6 volts. Why? They are parallel, in parallel network. Okay, that's parallel circuit. So that's the value of the voltage one. From there, the other question on 2.3 will be calculate the current through 5 ohm resistor, and then after that we will need to calculate the value of internal resistance. So if we're going to find the current through the 5 ohm right there, we need to understand something. That's what I'm going to illustrate now. Okay, let me just write it this way. When current is coming from the cell, this is current total. That current total is the same current passing through the 5 ohm resistor. But when it reaches this branch, the current will split, okay, into 2 parts. This one will be I1, this one will be I3. And then that current will come back here again after meeting this junction again as I total. It will combine again. Alright, so this tells us that current through 2, or maybe current total, will be equal to current 1 plus current 3. Okay, the current across the branches, if you add it up, it will be current on the 5 ohm resistor. Now, so current through 2 will be equal to I1 plus I3. So we know what I3 is. It's 1.5 amperes. Okay, now we need to know what I1 is. Now we have already discovered that the voltage here is 6 volts as well. So to find current, I1 will be equal to V1 over R1. So the V is actually 6 volts and the resistance is 12 ohms. This gives us 0.5 amperes. Okay, so if we're going to find the current through the 5 ohm resistor I2, it will be equal to I1 plus I3. If we add the 2, it's 1.5 amperes plus okay, so this is not I1, is it? So it will be 0.5 amperes plus 1.5 amperes. This gives us 2 amperes. So the total current is 2 amperes. Alright, that's very important. Let's find now internal resistance. If we're going to find internal resistance, first of all, let's calculate voltage lost. we know that voltage lost is equal to EMF minus terminal voltage. EMF is 17 volts and the terminal voltage is 16 volts. If we subtract the two, we end up getting 1 volt. But we know that voltage lost is equal to current times internal resistance. Okay, so this is equal to 1 volt. Therefore, internal resistance will be equal to 1 volt divided by current. In this case, this is the current total. So 1 divided by 2 amperes. This gives us 0.5 ohms. That's the value of the internal resistance. This is how you solve that.